Hello everyone, my name is Carl Schenzer, and today I will be presenting you a presentation on database. What is database? Database is essentially a collection of information that's organized so that it can easily be accessed, managed, and updated. This right here is the symbol for database. E.F. Codd really he published a paper on database computing, which essentially the idea and the concept of database being viewed in the computing community. And one of the first programs to have a database was the American Airlines program of Sabre. And this was paired with IBM, and this started back in the 1960s. The three major forms of database I will talk about today is relational database, which you can see right here, and then operational database, which is right here, and real-time database. Relational database stores data within various tables, and with the table is a key for which it can be accessed. So for example, if you were storing some type of data organized into one place, you would have a key that would be able to access that table and source of data based on some type of relation. And that's where the word relational database comes from. Little graphic right here. Relation is this right here. And that's how the common application, it's used in pretty much every form of database today. It's very, very common. Any type of database you use, you'll be using relational database. Operational database. A database designed to integrate data from multiple sources for additional operations on data. So basically this would be compiling different sources of information and data into one place, and then using that data to try and make sense and make new data which will be more effective than the raw data which was coming in from different sources. A use for this would be a supermarket. You would have the customer data, the employee data, and the store data, and you would use all of those together to try and make the best store you can and try and figure out the layout, etc. Real-time database is a database system that uses real-time processing to handle the workloads of those states, which is constantly changing. So basically this means like GPS, anything that's connected to the Internet of Things, which will constantly be feeding information to a database. And this will, in the long run, give you lots and lots of information. And the trick about this is real-time database. It's very important to be able to make use of all this different real-time information. Challenges to database. Like I said, information overload. Problem with that is you have too much data. You're not really sure what to make of it, and it means nothing if you can't put some and structure to it. Structured data, that would be an example of PDF, sound, movie, Facebook, social media, any type of that type of stuff. Structured data is the numbers, basically statistics that you can really measure. But with the difficulty of unstructured data is there's no real way to measure it. And so you're stuck in what to do and not knowing how to apply it, especially if you have massive quantities of it. This goes for infrastructure limitations, becoming less and less of a problem as technology improves. Problem to where the storage of the database would be your biggest limitation. But now it's really how much data you can actually compute and go through and make useful. Industry leaders in database, you have IBM, which has been around since the inception of database. SAP is one of the things that we will that is huge within the business world. Microsoft SQL is also another huge database. Database and the Internet of Things. So like I said, the movement in database is towards big data and real-time updates. So with the Internet of Things, everything's connected, everything's always communicating, and they're always telling each other information and sending information to the database. And this will really help you what the trends are, where the inefficiency is, and you can really better society and whatever program you want to use with this data. So data mining is the practice of examining large databases in order to generate new information. This is very important to talk about within the scope of database, because it's one of the most important things of database is taking these massive amounts of information and applying logic and common sense to them and finding the relevance, the trends, how they relate to one another. And from that, you can construct new data and make it relevant and make it with new information. And this will help with decisions that you're about to make. Database and real world application, like I said, data analysis leads to trend analysis, which leads to consumer behavior. Database is really just the information and trying to make sense of it all. And when you do make sense of it all, that's when you're really able to grasp the importance of database, not the storage aspect, but rather the predictive qualities that you can get from having this massive amount of information. Today, thank you for listening to my presentation on database. Thank you for your time.